Hello, my name is Aaron Gors, and this is my Project 1 presentation for CE 570. So to begin this project, I really had to fully understand the syntax that MATLAB was using to create these results. So once I studied through the material that was given within the code itself and felt like I had a good handle on it, I had to define a surface of my choosing. And my surface was a cylinder with a hole through the middle of it, kind of like a roll of paper towels, as you'll see in the next slide. And just going through some of the line of code that you can see in the very top image there, I have R1 and R2 both being the inner radius and the outer radius of my cylinder, h being the height of my cylinder, and t being the revolution of my cylinder, as 2 pi is a circle. The next is just defining the simplest parameterization of that cylinder, which is just r times cosine t, r times sine t, and z, which is the x1, x2, and x3 dimensions. Next, I had to actually define the surfaces, and this was a rather unique case, as there is, unlike any surface like this that was given in any of the codes, is there is a surface within a surface. So I had to ensure that those boundaries did not overlap with one another and were being properly implemented into my MATLAB code. So once I figured that out, I had to define my line and surface parameterization of my choosing. My line of choosing actually wraps around from the bottom of my cylinder to the top of my cylinder in one full revolution. And then my surface is actually a surface within my cylinder that spans from the inner radius to the outer radius at the full height of the cylinder. So here's an image of the cylinder output of my code. As you can see, the red line that wraps from the bottom to the top of the cylinder, the surface is in gray, and you can tell that there's different surfaces as I drag it around here. And then also the blue surface that's contained within the cylinder itself is the rectangle I was talking about before. So my code successfully worked at plotting what I desired it to plot. In this slide, I'll be going over the outputs that MATLAB actually gave me. So we were tasked with ensuring that there was a convergence as I increased the number of segments to my shapes. Now, since I had a rectangular shape, there wasn't a need for me to show that it was converging, as it was just a two-dimensional shape with an area of 20, because the inner radius is 1, outer radius is 3, that's 2, the height is 10, so 2 times 10 is 20. And then as you can see in the line segments, as I increase the number of segments themselves, all the way up to 2000, you can see that there is a convergence occurring at 21.3379 units that wraps around the cylinder itself and converges at that location. Before I began coding any of my cylinder into MATLAB, I first had to parameterize the surface by hand to ensure that I fully understood how this surface could be created and implemented into the MATLAB code. So that's what you're seeing here, where I worked out the parameterization of a simple 3D cylinder in both the x1, x2, and x3 dimensions respectively. As you can see, the r cosine t, r sine t, and z, both being the height and then the radiuses and the different locations within the cylinder itself. And then I had to define the limits. So with R was a unique case where I had an inner radius and an outer radius to ensure that the surfaces were only getting plotted within the locations that I wanted them to be plotted. T being theta within the code, to where it would revolve around the edges of the cylinder in a circle, and then Z being the height. Finally, I was able to verify the length of my line and the area of my surface by deriving the formulas from hand. As you can see, the equation of the helix is given there. L is equal to the square root of the total height of the cylinder, h squared, plus 2 pi times r2 squared, r2 being the outside radius because that is where the line revolves around the surface of my cylinder. And then I plugged in my actual values that I used in MATLAB, and you can see the matching 21.3379 as my total length of my line segment, which matches my MATLAB output. So this was able to be confirmed by hand using an alternate method. And same thing with my area, it just being a simple square, I was able to just use the basic area of a rectangle, base time height, my height being 10 and my base being 2, since I'm just plotting within the inside of the cylinder. 3 being the outside radius, 1 being the inside radius, subtracting the 2 and resulting in 20, which matches my MATLAB output. So thank you for watching.